먼 곳에 있는 수행원들은 잘 있는지.
모험가 길드의 모두 걱정하실 필요 없습니다.
Okay, I'm back, guys.
천지 우주를
back.
창조하고
Thank you.
땅을 가른
I'm back
내가 바로
also.
단지의 황녀.
Welcome back. Oh, Olivia Ninja just asking, how is / was everyone's day?
Okay, we still have Winnie
Friends,
on
doing really well. How about
from the previous
yourself?
stream.
Which was an ASMR.
I'm gonna lurk in her stream with
Aw,
a
Olivia Ninja
mute.
says, I'm doing well. I had a busy day, so the stream is a nice way to end my night. Ringo says, just having fun.
How do I?
Harry says, bad Genshin is not giving me a 5-star.
What am I actually looking at? Oh, my mute plugin isn't working. Anyway, we are starting our second stream of the day.
Olivia Ninja says, Ringo, that sounds awesome. Always good to have some fun.
Is it because I'm hosting her?
Brent
Yeah.
says, watching streams
no.
after a long day can be so relaxing.
Which tab is this? Where I'm still here, Minnie?
Wait, Olivia
Where-
Ninja says,
Minnie?
she's back.
Winnie.
Charmy says, oh, thanks for wishing
Oh,
me good
I'm
luck. I'm gonna need
lurking
it.
in two of her tabs. Okay. Cool. So I can continue lurking, and in the meantime, we are doing the electronics project. Day number, which day is it? I think this is the fourth session that we've done this. The first session we did parts. The second session we did. First one we did like the LED, just one LED. Second one we did the LED strip. Third one we did put the potentiometer from last stream. Where is it? I think I knocked it off just a while ago. Yes, so we have the potentiometer here. So this was our third stream. And then our fourth stream today, I finally got the part in for the microphone. Yes. So today we will be able to, or I hope we will be able to put this little part into use. I should be able to speak into it, and I should be able to change the color of the lights. I still don't have a lot of the code written yet, but hopefully we can do a proof of concept today just to make sure that we know how this thing works. This is one of the rare streams where I actually didn't do enough preparation, and I don't know if we're going to have a successful result. This microphone, it comes with a spec sheet, it comes with instructions on how to use it and program it. But it's also a very standard part, so if other people can get it working, I'm sure I can get it working as well. Okay, so without further ado, let's go over to the desktop. Hello Alex, welcome back to the stream. I'm glad you're here to chill with me as always. And we got Roman also here doing the nya. Maria, well, I haven't seen you on forever. I'm sorry. So this is usually what I do on Sundays is for the Genshin folks, I'll send them over on a Genshin raid, and then I'll start a second raid exclusively for hardware and software engineering. Because, well, I'm not gonna lie to myself, most people aren't that interested in like writing code and learning physics and stuff, but I really am, and this is like in some ways this is my passion. Roman said, Alex says you can't get rid of me that easy. Bongo Cat, is that Bongo Cat? Bongo Tap. Roman says he tried getting rid of us. JK. Hello. I think for people who are interested in me for being me, then and you know they want to learn a little bit about these tiny little capacitors inside of these microphone capsules, then they'll be back. But for other people, you know, like if they came for the Genshin, I want them to be there for the Genshin, right? And the content is also a part of the content. I totally understand not everyone who is watching the stream is necessarily just there for me, and that's good too. I'm glad I can provide entertainment value for them as well. We said, Roman said he tried getting rid of us. JK. Maria says I have to focus on folding this dang laundry for like the last 2 hours. Maria, oh my goodness, it's been such a long time. or I won't be able to sleep, so I'll be watching the lurking. And I hope this will be a very chill session for you, because this is definitely the more chill part of my stream, where you know, we put on the lo-fi. We're doing a little bit of coding. It's not going to be too quiet, but it's going to be hopefully a little bit more educational. This is kind of wind down time for me as well. Like for me, this is very similar to putting Legos together. This is very like therapeutic. I know I'm talking really fast, and my words per minute is probably around 150 to 200. But I promise I will be slowing down as the night progresses. But yes, thank you for the lurk, and I hope you actually get that laundry done sometime tonight. So without even more further ado, we got that's Genshin. Genshin is something that needs to run in the background. Okay. Hey Dart, hello. Welcome to my electronics stream. You caught me during my chill hours. We just finished our Genshin stream, and we've moved on to doing programming. So what you see here with my this is an Arduino microphone, and then we're going to be programming it to control some of the lights that we were working with last week. Electronics pod, yes. I am a software engineer by trade, so I do like a lot of software stuff, obviously, but this is the first time I've dabbled into hardware electronics engineering, and I suck at it. But I hope you guys are along with me for the journey to learn some of this stuff, especially when it comes to physics. I hope I can provide a non-zero amount of educational value along with the chill vibes. So, for those of you guys who are new, this is a power supply. It's not too different from the one in your computer right now. Tazart says, electronics Puck, are you going to be using voice commands? I've messed with Arduino before. You might teach me quite a few things, Tazart. This is my first time messing with Arduino. Well, like today is not my first time, but like this is the first project where I've messed with Arduino, and I can definitely use the help when I get stuck. Are you going to use voice commands? I don't think the Arduino has enough memory to be able to hold enough data to hold an entire NLP, natural language processing program. So probably not, but I do want it to be voice activated so that the lights change according to what to the volume levels. How do you like your Logitech G Pro mouse? So there's a new version of this G Pro if you're looking, that has I think like a better sensor or something like that. It's slightly upgraded, but it's really good because it charges on without being plugged in, because this charging mat here, it charges the mouse, so I never have to plug this in, and I never have to swap batteries. And in fact, inside there is actually a very tiny battery that is very lightweight. Therefore, well, it's lightweight, and lightweight when it comes to mice is always good. Okay, so first thing that I want to do is I want to power the board that we have from the last VOD. I think I have some additional wires that I need to plug into the board in order to power it up. And then let me see if I can pull up the documentation for the microphone so that we can figure out how to program this thing. Yeah, this is one of the electronic streams where I haven't done preparation ahead of time, so I don't know if everything's going to work out, but hopefully we have a mildly successful... Yeah, we have a mildly successful results. I will lurk and listen. Thank you, Tazdar, and I hope that this will be an enjoyable chill process for you. That is the goal of the stream. Alright, so I've got black and red. Black is ground, red is positive. So we want black on black and red on red. So we're gonna go and plug in the ground wire. Is this long enough? This is not long enough. This one is long enough. We will plug the ground wire into our circuit board. And these are 5-volt power supplies, so I'm gonna turn this on. Nope, this is not. Okay, let's try that again. Okay, so we got 5 volts and 0 amps here. Or, well, it's 1 amps at the cap. Okay, and then we're gonna need our positive lead as well. Okay, that's gonna go into the positive lead of the breadboard. And hopefully I don't short circuit anything. Let's see. Is it time? Am I gonna smell burnt plastic? Let's see. Press. That's a negatory. Okay, so far so good. I'm gonna keep these leads just a little bit further apart so I don't end up shorting my circuit. Actually, I'm gonna pull this entire power supply back. Whip. Okay. All right. So everything looks good so far. There's an LED on the board that's just lit up. That indicates to us that the board is properly powered. And then the other thing we want to do is replicate last week's work. So last week we programmed a potentiometer, which is this little thing. It's basically a fancy knob in order to control the colors on our light. I'm going to plug that back in. Also have this doohickey thing. This is a Bluetooth module. We're going to be programming this in a future session, so that our circuit board can talk to our phone. Ooh, fancy. But for now, let's just try and replicate last week's work. We got the potentiometer. And I think it's still the same circuit wiring as last time. I'm gonna plug in the power for the lights. So that's just the red and white leads. And then I'm gonna need a signal. And here we go. We got our red, we got our green, and our other red, apparently. This is probably the program that we wrote last time to for the board to send over to the lights, for the lights to do what we think the lights are doing. But let me go and pull up that program on our desktop so that people can see. Arduino, Aruba. I have a file on my desktop called Aruba. Jamaica, ooh, I wanna take ya. Bermuda, Bahama, come on, pretty mama. Okay, so we got our fast LED that we ran last week. And hopefully this is still visible on stream. What does it say? It says setup. We're gonna be programming these WS2812 LEDs. That's the product name for the specifications for the LEDs. We've got some code that says we're gonna read from our A1 signal, and I believe that is plugged into the potentiometer right now, right? That's the blue wire. So we're gonna read that value, and then we're gonna apply that value to the coloring of the light bulb. So let's see if that still works with the same wiring. I'm adjusting the potentiometer, but I don't see any changes. We might have to do a little bit of debugging, but first, before debugging, I'm just gonna re-upload this, make sure that code is actually on the board. Did this work? Can't open COM3. Oh, it cannot, right, because it's not plugged into the computer. Alright, let's try plugging things in. Okay, this is the wire. Yeah, oh man, things don't work if you don't plug them in. Are you serious? No way. Alright. Couldn't be me. Okay. Plugged in. Can we upload this time? I think I made the exact same mistake last time. Alright. And I think it is in. If I adjust this knob. Nope, still doesn't do anything. Why? Let's see. So this is row number. Let me get my microphone a little bit closer without hopefully bumping it too much. We've got that in pin number 0, A0. We're reading that value. And these are all plugged into the leads. Okay. And those are all plugged into the leads. So what is it missing? I'm missing something. When I see it, it's going to be really obvious. Let me go and untangle this mess of cables real quick. And if I unplug this data lead is absolutely sending some signals. I just don't know what. And then where is it sending the output digital signal? It's on pin number 7. Pin number 7. And it's being skipped over by resistor. So all that looks good. Yet it doesn't do what we want it to do. I think there's something wrong with the wiring here, because that's the only thing that I changed from the last week. How much amp? We are only outputting 70 milliamps. Interesting. What is my LED count? 144 defined pin 7. So, and where is it outputting to? Fast LED is going on the LED pin. LED pin is number 7. But is this commented out? Why? I'm pretty sure the code is fine. Yeah, I think the code is fine. That's a good question. Why can't we reproduce what we had already last week? I don't fully know. But this is the fun part of programming, is debugging. Yes. Debugging. We all hate that word. Okay, let me check the... Okay, so the knob is plugged in the wrong way. You're supposed to plug it in so that each one of the 3 pins is in its own row, but I've plugged it in so that 2 of the rows are the same, which does nothing. Okay, so let's plug that in the correct way this time. And immediately we already got new colors. So we got orange, green, and purplish. And oh, okay. No, I had it in the wrong rows. Now it's plugged in correctly. So we got purple, green, and blue. And if I twist this, oh yeah, there we go. Now it's yellow, cyan, and magenta. Ah, okay. So now we can finally reproduce what we had last week. It was a wiring issue. It was a wiring issue with the knob. But this week, let me see if I can go over to the side cam. Yes, so now the colors can change according to my knob input values. You can see that it's slowly changing as I turn the knob. But let me go back to the desktop. Because today we're going to be looking at a new schematic or a new diagram. So I purchased these microphones. I think, what are they called? Arduino microphones? Arduino microphones. What do we got? It wasn't this one. I think I purchased these ones. Let me go and check my personal account. I usually try to avoid this on stream because I don't want to get doxxed, but at the same time, I think the text is way too small for the VOD to pick up anyway. Where was it? Right over here. Best 5-piece microphone sensor module LM393. So that is this, not the serial number, but the model number that we can look up. LM393 Arduino, and I think there's a microphone. Maybe we can find a tutorial of some sort. Tutorial. Yeah, so half of programming is debugging, the other half is looking up random stuff on the internet. Let me see if I can make that really big for you guys so that it parses well on the VOD or in the stream. We got guide for microphone sound sensors with Arduino, and I think we have the model on the right hand side. If I switch over to the camera for just a second, yep, I do believe this is the correct one. There's also like a blue cross section here. I think this is used for adjusting the gain with like a Phillips head screwdriver. So we got some pin wiring. We got A0, D0, so analog and digital. Ground is just ground, and then VCC is 5 volt. I think that's for the red schematic, but we have the blue schematic. Parts required. We got a sound sensor. Okay. And here's the wiring that they expect us to use. Let's see if we can understand this. It seems like there is, just like with our LEDs, it seems like there is a positive, there's a negative, so red and black, and then there is a digital wire coming out of the middle. So just 3 pinouts, and it seems like it's pretty easy to wire up. Ah, there it is. Someone snapping their fingers and then it triggering a LED light bulb. That's exactly what I wanted as well. Although I'll probably need to read the value a little bit differently. Let's see what the code that they've written does. It should be just like read the signal and then write the signal. That's it, right? Like, you know, you hear a sound and then you want to have the light turn on. Should be relatively simple. So they have 2 pin numbers defined, number 13 and number 7. These are just like pin iteration numbers for the holes that are on the Arduino board. So like I think they have their yellow wire plugged into the 7th pin, so it's just pin number 7. So sensor pin is number 7, LED pin is number 13. Yep, and they have it wired up exactly like that. So number 13, it goes up to a light bulb. Okay, so our setup says LED pin is output. That makes sense because we want to light it up so that it's output. And then sensor pin is input. So that also makes sense because we're reading from there. And it's saying serial.begin. So I think serial, when the serial library, when you call it, it means to go and read digital values out of the digital pins. And the baud rate that it's set at is 9600. Is that... What is baud rate used for? Oh, okay. So it wants to write over to a console just like last time. So 9600 makes sense. And then for the actual loop code, it's just reading from the sensor pin and then storing it as an integer. I believe this is a Boolean. It's storing it as a Boolean in val. Okay, that might be kind of complicated because if it's a Boolean, it can only be 0 or 1. And if it's 0 or 1, then that might not be super useful for us. Okay, so it reads from the microphone and then it turns into 0 or 1, and it will print out the value. Okay, we might want to just do that first, just to like print it out and see what the microphone is giving us, whether it's 0 or 1, and like maybe while we're talking, it's just 1 somehow. I mean, usually microphones are it's a time series analog value, which means that it's wave. So I'm surprised that it would come into the digital port instead of the analog port. So if the value is high, and high I guess means 5 volts, then also turn on the LED, otherwise set it to low. That's kind of interesting that whoever wrote this tutorial decided to use the digital pin instead of the analog pin. Yeah, is there anything else that they're telling us about this little module that we're using? The LM393, this is the microphone module we're using. Coming from Texas Instruments, this is a PDF. Oh my goodness, this is quite a PDF. A lot of physics terms, a lot of schematics. So there's some at some point I'm gonna spend some time to explain all the little symbols on the schematic. But to be honest, I don't fully understand it myself. I just know that most microphones work as speakers as well. There's magnets inside of them, and then the magnets create electricity. Magnets, how do they work? Who knows? It's kind of almost an interesting question as well, because when it comes to science, like, and you say like, okay, I know how magnets work, what does that actually mean? Well, it means like, you know, maybe you have a set of equations that describe some predictable property of what happens if you put 2 magnets really close, right? Like you have an equation that predicts the force that you're gonna feel, but does that mean you actually understand how things work? Well, I guess it kind of does, because you can predict the future. That means you can understand, right? But sure, you can predict the future in that scenario, but how can you predict what happens when, say, a 5-volt current is going through a wire next to a magnet? Well, the original formulas can't predict that. But then, does that mean you still know, you still understand how magnets work just because you can write out a few formulas? Like, science is such a weird field, because as humans, we're not programmed to understand the universe. The best that we can do is generalize it about it. The best that we can do is write some equations that predict how things will happen given a particular set of inputs. But what does it actually mean to understand something then? Does it mean that, like, you can predict the position and force of certain vectors? Or does it mean that you have some deeper intrinsic understanding? Like, in other words, if I built a calculator and all it does is calculate how magnets interact with each other, does that mean the calculator has knowledge? Science is kind of a weird field, right? Because just because you can generalize about a system doesn't mean that you understand, you have information about every single component of that system. Which is why it's always an imperfect field. There's no hard laws. There's no hard there are some laws that are proven over and over again, but you never know something 100%. You just have a lot of data that supports a theory, right? Philosophically, science is it's a topic that doesn't get talked about enough. Anyway, let's nature of knowledge aside, let's see if we can actually program this thing. So I'm not actually picking up that much information here that I can easily process. This might be a little bit too detailed of a specification sheet for me. What I'm actually looking for is whether or not I can get, like, decibel data out of this thing, because the tutorial we just found says that you can get, like, a Boolean value, but a Boolean value is either 0 or 1, true or false. And microphones aren't Boolean devices because you can be really loud, right? And the loudness can be like 20 decibels. Whereas if you speak quietly, then that should only be like 5 decibels. It's not 0 or 1, it's like between 0 and 100, something like that. So we're seeing if we can get a different tutorial, and whether or not we can actually use this with the analog. With the analog side rather than the digital side. Okay, so this is a tutorial on using the LM393, which is what we have. Wait, what? This is a photosensitive sensor. Is this? This is a light-dependent resistor. Okay, never mind. This is a... I think the proper term is a photoresistor? Phototransistor? One of those two. Are we actually even looking at the right part? Let's see. Yeah, this is the LM393 Arduino tutorial. That was not what I expected it to be. This is the resistor? Okay. Let's skip. How to interface. The light. The speed sensor. Now this is a speed sensor. Oh, maybe the LM393 is just a chip that's on the device, but it's not the name of the full board itself. Yeah, that's the chip, LM393. So that might be kind of hard for us to decipher programming just from the chip. Can we get a different tutorial that uses this specific part? Microphone sensor. Maybe we just search for Arduino microphone sensor. Arduino. I think that's how I found the chip to begin with. I think we were just here. Okay, that's cool. This one uses a slightly different microphone, but the wiring schematic looks similar, and the out signal goes to analog instead of digital. Interesting. When we go on Amazon, does it have... That's the circuit diagram. And here is a wiring schematic, and then this one says to send it over to digital as well. Interesting. Okay. Right, because it's this one that uses analog. I don't think this is the same part. Using a microphone with Arduino. Alex says, looks complicated. Yeah, it looks a little bit complicated. And I think the version that I purchased, right, okay, it's slightly different circuit design, but mostly the same. It's different because I think a lot of people are using the red one. I'm using the blue one, and the red one has 4 pins. Yep, and the red one goes directly to analog. Does the blue one not go to analog? Did I purchase the wrong part? That would be really sad. I got 3 pins here. Yeah, not 4. What does this one do? This is like half of what I spent my time on when I'm at work, is just looking at tutorials and documentation, because like programming is like, it's such a local field. Like when you have knowledge, it's usually in a very, very narrow area for a very specific topic, for a very specific part, for a specific library, for a specific language. But despite how many different realms that you can be debugging in, there are patterns that extend between use cases when it comes to programming, and those are the algorithms. Those are the operating systems. Those are the common pieces of knowledge that they teach at school, because very rarely do you come across the same problem twice, but it's very common to solve the same type of problem multiple times. So let's see how this one does it. It seems to also use a different microphone. Oh, that is really sad. Let's see if we can find one for our specific part. Again, this is apparently the LM393 microphone tutorial. Let's try that again. And your ability to search and be like a Google ninja, like knowing exactly what to search for, a lot of times is more important than the data that you're actually obtaining. Gonna lurk for a bit. BRB, thank you for the lurk, Alex, and hopefully you enjoyed the alternative activities. Okay, I think this is the only one that we found so far that is using our exact microphone. It's kind of strange that they picture it with both microphones. Left side is the KY038, and then on the right side, LM393. Oh, this also looks same. Looks like we have 3 pins for this one. That also looks correct. We have a power LED. This thing has a power LED? This tiny little thing? My goodness. Yeah, it does have a power LED. And then there's a status LED. Yep, this actually looks almost exactly the same as ours, except that the microphone is situated and pointed off to the side. We got 5-volt in, we got ground, and then we got out. And then they say to plug it into also the digital side. Interesting. So is this like a basic like on and off microphone, as opposed to a actual diaphragm where you can get like the decibel value? I don't know, but let's see if we can get to a working state first, and then let's go and modify it. So we will take this tutorial because I think this is the best that we've got. Maybe I need to purchase some additional parts for getting analog output. It would be analog input, yeah. But for now, given the part that we have, let's use the code that is suitable for this part. So Mr. Santos here, thank you so much for your contribution to our knowledge. we're gonna use your code. We're gonna wire it up just like your diagram says. So it's just it seems like it's just a very simple, are they using they're not even using a resistor to filter out the signal from the digital side. One thing I have to be careful of is the voltage going into the microphone, because the microphone, it's probably rated for either 3 volts or 5 volts, and my Arduino is a 5 volt Arduino, so like 5 volts means on and 0 volts means off, as opposed to 3 to 0. But let me make sure that I don't burn out one of these components because I used the wrong voltage. So voltage says operating voltage 4 to 6 volts. That's good. Okay, that's exactly what we have for our Arduino. And then instructions, 5 volt is connected to the 5 volt voltage, ground is connected to ground, and then the power indicator will be on. So let's see if we can do that first. So I'm just going to plug it into the board directly. Rows number, let me bring my microphone over for a bit. Rows number 15, 15, 14, and 13. And then let me go and wire up the input and output. Hopefully I have plugged in... Oh, okay, it's labeled on the board itself which one is which. I have like 4 of these, so I should be able to just... okay, I'm just gonna unplug it and see. So top is 5 volt, and then middle is digital, and ground is the bottom one. Okay. And then I'm gonna use wires to hook everything up. I am out of red and white wires, so I'm gonna have to use some funky colors here. Real funky colors. We got a black one apparently. Nice. And we'll use an orange one. Black and orange. I think that's top and bottom. Okay, we plugged it in, and there is an LED on the board that is slightly red. Not sure what triggers the red LED on the board. It's really, really tiny. It's also possible that my wires are not the highest quality. Let's try with a different wire. See if it stays lit. Stays lit, as the kids call it. Oh, it like blinks for a bit and then it turns off. Hopefully it's wired up correctly. So if I rub my finger over the microphone capsule, then it definitely lights up. So it might be lighting up according to activity. I'm gonna clap. Yeah, okay. So the LED on board does light up according to the voice, to the audio activity around it. And then I'm gonna go and plug this into pin number... Oh, that's a little bit far. Gonna need a longer wire. Pin number 7 probably, or get one of the green ones for data. Okay, we're gonna use pin number 8 for the microphone. Wonderful, wonderful. So we're gonna have to change this code a little bit because we are outputting to inputting from pin number 8, and we'll save this as microphone. And we're gonna be outputting to pin number 13. Is that right? We do have an LED on board. Number 13 for the LED, and hopefully this just runs. Gonna upload it and see what happens. Okay, the LED is on. And it's just on. Let me go over to the side cam so you guys can see what it looks like. But basically, this LED is on, and not much else is happening. I don't know if you guys can see it, but like if I rub the microphone capsule a little bit, it should light up with the onboard LED. Onboard LED. It's really tiny though, so I wouldn't be surprised if you guys can't see it. So this is not what we wanted, because we are expecting the light bulb to be only lit when there is sound. Let's take a look at something else then. Let's take a look at the console that we learned from last time. I believe that's the button on the top right. Serial monitor. Yeah, serial monitor. So let me go back over to the desktop. We're supposed to be reading values from the microphone. That is not supposed to be 1 all the time. And it seems like it's 1 all the time. That's not good. Okay, let's take a look at our code. Sensor pin is number 8. That's correct. And when it's high, then so every iteration we are reading from the sensor, and then we are printing it out. Huh. So maybe the microphone is broken? Maybe? Okay, so that's one sign. So if I unpower the microphone, it's just 0 all the time. But if I power it on, it's giving me 1 all the time. And I think we expected something else besides 1. Let me try a different microphone just in case if it's something faulty with the hardware. Because sometimes you do get hardware failures. And it's not always the fault of... it's not always the fault of your wiring. I see the LED like randomly blinking. I'm not entirely sure why. Because it's supposed to be controlled by the value that's being read. Huh. And right now the value that's being read should be static because we've unplugged the microphone entirely. I have a pair of scissors. Okay, I'll be right back. I'm gonna go and cut this bag open. So the bag is open. We got our brand new, fresh out of the electrostatic bag, brand new microphone. And let's plug this one in and see if it does any different. This one also constantly outputs 1. Starting to think that it's not the fault of the hardware at this point. One thing that I haven't fully adjusted is that this board has a blue little knob on it, and I believe that is for the gain. So it might be that the gain is like default set to really, really high. And I just haven't had the chance. I need to actually use a Philips flathead, or actually Philips had flathead, a Phillips screwdriver in order to adjust it first. So let's go back to the desktop. Let's see. It says specifications on Amazon say when sound intensity. So this particular microphone is tuned for a specific sound intensity to digitally output 0 or 1. So it's it definitely doesn't output analog values between 0 and 1. It's just 0 or 1. I might need a separate different microphone to have intensity be a scalar value as opposed to a Boolean value. What else does it say? Different intensity, certain threshold. And I believe this, the little blue knob on it, that's right here, is how you set that threshold. But let me go and verify. Voltage connected to ground. Can I search for threshold? Yeah, built-in potentiometer can be used to adjust the threshold level. Okay, so I am gonna need a really tiny Phillips screwdriver in order to adjust this threshold level. I'm fine now. Okay, I got my tiny little, my ridiculously tiny screwdriver set full of ridiculously tiny screwdriver heads. Let me see if I can find one that's like comically small. Okay, I'm on desktop right now. Let me go over to SideCam. So this is a set that you can get on Amazon for not that expensive. Tell us hello and welcome to the stream. So we are doing the microphone today. I finally got my microphone module for Arduino, and we are figuring out how to have it control the lights. So we downloaded someone else's code in order to see how the module worked, and it seems to output a binary signal. So it's a Boolean value, which, like, if you know anything about microphones, usually it's a scalar value, right? Like it's measuring the sound pressure at that specific moment in time. But this microphone that I purchased seemed to give me a Boolean value. So instead of telling me what the sound pressure is, it tells me whether or not the sound pressure has reached a certain threshold, which is less useful. So I might need to purchase additional parts for this, but let's make the best of what we got. So I guess this is probably better shown on the desktop. I purchased this off of Amazon. It's like a pack of 5 for $10, and apparently this blue section of the module can be used. We can use a Phillips screwdriver in order to adjust the threshold, but it's still a binary signal, which is not very useful. So I'm a little bit disappointed by the by the fact that it doesn't do what I want, and also by myself not having done enough research before I purchased this component. But we can still make a good use of this. So I don't even need a screwdriver for this. Let me go back over to this side cam. I don't even need a screwdriver for this. I can just use a flathead to adjust. So previously we were reading a lot of 1 values, and that means that the threshold is too low, I guess. And I'm just gonna twist this maybe 1/4 of a turn. I did 1/4 of a turn clockwise, and then we're gonna plug it back in. Okay, I did a 1/4 of a turn clockwise and plugged it back in, and the onboard LED, which I think is this little thing, is now very well lit. That is desirable. Right, okay, it's still on the side cam. That's what we want. So I'm gonna rub the capsule a little bit and see if that color changes. Nope. Still nope. And now it's giving me all zeros instead of all ones. Interesting. Interesting. Okay. Toast says, do you usually work with software or hardware? I absolutely do software. I am scum at hardware. Not scum, scuff at hardware. So all of this is new to me as well. I'm here to learn as much as anyone else in stream is interested in learning what I'm doing. So I realized there's a turning operation that's available with my Phillips screw head, and I can turn it all the way to the left or all the way to the right, and previously it was set all the way to the left. And I think if I plug that in back again, right, so it's giving me ones all the time, including on the desktop. So like the Calm 3 serial monitor at 9600 baud is also saying 1. Actually, I think I can adjust it while it's still plugged in. Hopefully I don't short the circuit. Okay. Whoa. Okay, so I've adjusted barely past the threshold where it turns on all the time. Let me go backwards a little bit. I see whenever I'm tapping on the circuit board, it definitely turns on. Nope, maybe it doesn't. Let me turn it back just a little bit, which means I think this is more sensitive. Okay. And it's just on all the time. And then this is less sensitive. Okay, so it seems to blink whenever I clap. I don't know if the camera is fast enough to catch it. At least it seems to clap sometimes. I definitely need better microphone modules. But I'm gonna see if I can find the right threshold between 0 and 1 by turning this knob. Like blinking. Okay. I think if I bring it close to a sound source, it might be a little bit more sensitive. Testing. Oh, it's not doing what I expected to do. This might just be like a really crappy component. I'm not gonna lie, I mean, at like $10 for 5. I wouldn't expect this to have really good quality, but I did expect it to have a non-zero amount of quality. Okay, so I can make it when I'm clapping. It definitely lights up. Predictably, okay. But my voice doesn't seem to trigger it unless I get really loud. Ooh, I think we're at a pretty nice ratio between too sensitive and not sensitive enough. I'm not sure if you guys were able to see on cam, and we are not on cam. We are on desktop, and now we are on cam. Let me see if I can reproduce that. So it's blinking whenever I'm clapping, but I don't know if the camera is fast enough to capture it. And let me try the voice again. Yeah, hopefully that I didn't block that with my giant head. But it is definitely getting lit whenever I'm speaking, so I seem to have gotten the potentiometer at a good level. Carry Cat seems good, thank you. And thank you for the camera check as well. is kind of amusing now because as I say things, it's lighting up an LED, and that makes my inner child really happy, because like it's almost like a destructive behavior that like your action have consequences, and now you just want to overdo those actions. I somehow managed to turn on my entire LED strip. I believe it's random noise that's being sent from the board over to the power, to the random noise that's sent to the control pipe of the LED, and it just lit up the entire chain like a Christmas lamp. Whoop, yep. Okay. Or did I short circuit something? What? Okay, no, we're at 777. Well, very nice number. 770 milliamps, which is quite a lot of energy, but that's because the light is on. And our sensitivity adjustments seem to have been thrown off as well. What? What happened? Oh, something happened. Okay, let me rerun this program so that we flush out all the buffers and hopefully clean up. Okay. So all I did was I re-uploaded the program, and then it seemed to maybe it might still be a little bit too sensitive because it's on all the time. Why is it on all the time? Is it grabbing vibrations from? Okay, I'm just gonna readjust it. Where is my tiny little flash screwdriver head? I think if I unplug the LED strip, maybe it'll turn off. Nope. Okay, so once it's set to a certain color value, it'll just stay at that value. I'm gonna turn off the lights. Yeah, there we go. I can. Nope, I can't even turn them off. I'm gonna unplug the lights because I can already feel them getting really warm. 700 milliamps is a lot of power. Let's go and unplug the ground lead of the lights. Okay. And now the LED, which is running the program, is now just completely dim. Hello. Okay, that's not bad. Still does what we expected to do. Sorry guys. I know we're supposed to be having a chill stream, but my inner child came out where I just really wanted to talk to LED, and then talk to the microphone, and then get the LED to shine up. All right. What are the values that we're getting out of desktop? Okay, still zeros. But the LED's still lighting every few seconds. I'm wondering if there's like some sort of a system noise that is making it light up. Interesting. So now that we can get some value, even though it's not a very useful value, some values out of the LED, let's have, like, whenever it detects noise, let's have it change the color of our strip. Yeah. Because we can get it to light up the red strip, but we actually wanted to light up our entire strip. So let me go and plug the strip back in, and let's see if it resets in terms of color. No, it does not reset in terms of color. So we're gonna have to combine our code, and in the meantime, some of these wires are gonna get a little bit hot because, well, we're sending a lot of current through those wires. Actually, let me rerun our old code so that it turns off all of the LEDs except for the 3 at the very beginning that we programmed it. Let me roll this up a little bit so it's easier to see on camera. Camera, side cam, okay. I have like a little piece of tape here just to make sure that it doesn't get too untangled. Yeah, definitely an oop moment. Where is a little piece of tape? Huh, I don't see it anymore. Okay, whatever. I'm gonna have to get a new one. But I think from this moment on, from here on out, I don't need to touch the circuit diagram anymore because I have all the pins connected to the board, and I just need to read from the right hole. So let me go back to the desktop. Here we are. So instead of having just 0 through 9 show, let's have 0 through 0 through, or sorry, instead of just 3 light bulbs showing, let's have all 20 of them showing. And for that, we're gonna need a for loop. We have honey choose apparently. Oh, did Winnie raid honey choose? That sounds like a probability. Whoa, some ASMR page turning from the soundtrack there. Yeah, so we're gonna need a for loop for the Arduino. For loop. That way we can light up all 20 LEDs without having to write 20 lines of code. So it seems pretty simple. All we have to do, let me see if I can make this a little bit bigger. So all we have to do is for I equals 0 and I is less than 20, I plus plus. So this is a loop that allows us to initialize a value at 0. We want to increment it on every iteration of the value, and then we want to keep doing this until it reaches 20. Okay, and then oh, this line got cut off for some reason. Anyway, so we want to set all of the lights in between to some value. I don't know what. And then we want to show it once everything has been set. Let's just see if this works. So it should give us 20 lip bulbs. Lip bulbs. Okay, we got some orange bulbs. They are good. And I think they are still adjustable by the, yep, the colors is adjustable by the potentiometer that we installed from the last session. But instead of the potentiometer, we're actually gonna read this one. We're gonna read this one from our new pin, which is the microphone. So first of all, I'm gonna need to set a pin mode for the sensor pin. Pin mode for the sensor pin, and the sensor pin is number 8. Okay, so that should be just like very basic basic operations just to get started. And then once we have the pin set up, we're gonna read from that pin. Yes, we want to read. Instead of reading from the potentiometer, we're gonna do a digital read on the sensor pin. Okay, we're gonna set that to val. Let's call it a more useful name than val. Let's call it microphone. Mic value, just mic. Okay, and then it starts off at 0. And then the microphone value is red, and then once it's red, we want to feed it into the LEDs. But we want to feed it into the LEDs in a way that is interesting. So what I'm gonna do is whenever the value for the microphone changes from high to low, I want it to generate a random color. So as I'm speaking, it'll show off various different colors. So we're gonna need a Arduino random number generator. RNG, literally RNGs. Not a video game anymore. We're actually doing the real maths and the real programming. So it seems like it's just a function. You give it a max, and then it returns a number in between max, min and max. Okay, cool. And this is not a float number, which is what we want. We just want a discrete integer. So this example gives us between 0 and 299. We just want one that's like between 2 and we just want, actually we want 3 numbers, right? For R, G, and B. Maybe we do R is random from 0 to 256, which is 2 to the 8th power, and then G, and then B. So we generate 3 different numbers, and then we just plug it in. R, G, and B. Ooh. But we only want to generate new numbers if it crosses from high to low. That way, when there's no activity, then it doesn't change colors. So we're gonna read the value from the microphone, and then if yeah, so we're gonna need to have one value to store the old value, and then we need a new value. We need a second value to store the new value. Let me go and declare all of that here. So we also have int R is, let's start it off at the highest value, just so that if something goes wrong, then at least we can see that it is still a lit LED. It's a little bit of extra help for debugging in case if none of our code gets executed. Besides that, we want old, and let's start off at 0. And then we want new, that also starts off at 0. So we don't need mic anymore. We just need old and new. Or I guess maybe we can do old mic and new mic. Okay. Sensor pin is, yep, everything else looks good. So if we'll do new mic is read the value, and if the new mic value is not equal to the old mic value, then we generate. Okay. Then we regenerate these colors. And then at the end of our loop, let's set old mic is equal to new mic. All right, let's go and upload and see what happens. Okay, immediate. Oh. Hello? Not exactly doing what I wanted to do, but pretty close. Like I believe it's picking up a lot of vibrations from the table and changing the colors. But if I stop talking for a bit, it kind of calms down. Still a very noisy circuit, I'm sure. Like I really need an analog value out of it rather than a digital value out of this. Yeah, we're getting a lot of different colors. It's definitely party parrot time. Let me see. I'm going to clap and let's see if it changed the colors. Oh my lord. Might be a little bit too sensitive. What do you guys think? Probably. Also very inconsistent. Ooh, let's see if we can get the value show up on the LED pin as well, so that at least it blinks the LED whenever the values change. I might also want to have a, well, yeah, some sort of a buffer, right? Like if it changes too often, then don't change. Because what we're gonna do is we're very likely gonna get like a lot of, we're gonna get a lot of zeros first, and then we're gonna have a mix of zeros and ones. And then later we're gonna have a lot of ones. And I think the transitional period where there's a lot of zeros and there's a lot of ones and there's a mix, that might be what it's struggling with. So maybe I can like, that is extremely distracting. Let me go and, yeah, let me go and comment out this code for now and upload it just so I stop getting distracted by the roving lights. Okay, so it's just bright now. Yeah, okay, it's just 10 maximum brightness bulbs. But let's go and rate limit this so that It only at most changes colors once every or I guess 100 times per second. So let's do a delay here. I think it's delay, right? Let's see. Arduino delay. Delay. Yeah, I think it's just delay. And then you give it more milliseconds. So we'll delay for 10 milliseconds. That way, at most, this loop runs once every 100 seconds. And maybe this helps. Maybe that doesn't. Okay. There's also the... Oh my god, it's still so fidgety. I might need to average the values here over a period of time. Let me go and re-comment this out, because maybe the logic that we want to have isn't if it changes, but over the last, say, 10 milliseconds if it changes. So we'll have the delay here, and then we only have a 1 second delay. Let me go and upload this real quick so that I stop getting distracted by the strobing. Okay. So we have this loop run once every, or 1,000 times every second. And then over the course of every 10 milliseconds, we'll average the values. Okay, yeah. So let's have this loop, and then we'll have a int ms counter equals 0, and this will just go from 0 to 10. So at the very beginning of the, or I guess at the end of the loop, we'll have ms counter, milliseconds counter, plus equals 1, or can we do plus plus? I think we can do plus plus. Okay, I'm too used to Python. And then we'll also do if it goes over 10. If it goes over 10, let's reset it. Equals 0. Right. So if it goes over 10, we can reset it. So this I'll just count to 10 over and over again. And then in the meantime, we'll make it so that, yeah, let me put this plus plus at the beginning, or would it be at the end? I think it'll be at the end. Okay, and then this needs to be at the beginning. Okay. Right, okay. So we'll have this counter count from 0 to, actually from 0 to 9 will count. And then whenever the value is 0, actually, let's do whenever the value is 9, which should happen every 10 times. Whenever the value is 9, then let's aggregate all of the reads from the last 10 milliseconds and then see if the average is high. So once every 100 times every second, we'll do this check. Yes, 100 times every second we'll do if total mic is greater than 5, then generate new values. So we've smoothed out our fidgetiness, but we haven't defined this value yet. We haven't defined what total mic is. So total mic should be whoops. Yeah, total mic should be associated with new mic. So a new mic is when we read the value and it's either 0 or 1. And then we're just gonna increment total mic by new mic. Okay. Let me get rid of all these other code that we don't need anymore. We also don't need old mic anymore because we're not just comparing against the old value. Okay, and then we also want new mic. once the counter is at 10, then we reset new mic. So you have 10 iterations to try and get over 5. And if you fail, then too bad, you don't get to change the color. And this happens every 100 times a second. Okay, let's try this. And we don't need old mic anyway. Okay, cool. Yeah, let's just go and upload and see what happens. Total mic plus equals new mic does not work because total mic was not declared because we forgot to put it up here. So we don't need old mic anymore. We'll just replace it with total mic. Okay. It seems to be uploaded. Still extremely fidgety. Stop. Why don't I turn on the console and let's see what values we're actually getting for a lot of these. So a lot of times the best way to debug is to step through it one little bit at a time. Okay, and for the console, we're gonna need to set a serial baud rate at 9600. Why did this person add a space before the parentheses? Whatever. We'll put that in the setup, and then we should be able to print stuff using serial.print. Okay, so whenever it breaches the threshold, actually, why don't we every iteration? Let's just go and print out total mic and ms counter. Can we have two things? Serial.println. And then can we format a string? Let's do Arduino. Serial print. Serial print. Let's see. Okay. Seems like some examples. We can print ASCII encoded characters. Okay. Doesn't have too much on. Maybe we'll just print two values. Or print twice. One for total mic, one for new mic. Oh, I set new mic to 0. I didn't set total mic to 0. Okay, that might be why. I already found my bug, maybe. Yeah, let's try it with the bug fix. Okay, it's uploaded. Definitely a lot less fidgety. Maybe not fidgeting enough now. Also not lighting up our LED, which I wanted to have to help debug. Let's try that. And maybe 5 is like too high of a value. Maybe we need something a little bit lower. LED pin, okay. LED pin is number 13. That's our red LED that's just by itself. It's not a part of the strip. It's on the board. Okay, let's try that again. Val is not declaring the scope. This is on, oh, right. We don't call it Val because Val is a terrible name. We call it new mic. New mic value. Okay, let's try that. Okay, I see the light bulb lighting up every once in a while. Lighting up as much as it used to. Let's run the old program. Maybe I set something up with the new program that's and it's just lit. Okay, I might have to call this one a failure just because the hardware here is not as precise as I need it to be. I mean, precision, accuracy is probably there, but precision is about the range of values you can. And right now we get one of two values, 0 or 1. That's not good enough for a microphone. Yeah. Hello? Yeah, this module might just be outputting garbage values compared to what I need. It wouldn't turn off. It wouldn't even turn off. Yeah, I might have to go back to Amazon, redo the shopping, and then come back next week. Okay, that seems to work at that sensitivity. Let's try it again. And maybe let's set the threshold a little bit lower, maybe at 2. Oh, I forgot to actually enable the code for switching. Yeah, that's kind of important. Yeah, whenever you breach the threshold, then don't do anything. That's exactly what I need. Oh, I clapped and then it turned blue. Nope. Oh, and now it's turned slightly green. Oh boy. Let's try that one last time, maybe with the lowest value. Oh, I clapped and then it changed colors. Nope. That light bulb's not going off, which means that it's a problem with the module itself's sensitivity and not with my code, unfortunately. Now it's too. Yeah, like I'm pretty much doing that thing where you take a shower and then like you're like, oh, if only it were a little bit warmer, and then you turn the knob and then it's like freaking lava. Yeah, I'm gonna need better instrument for next stream. I'm gonna have to call this one a failure. We don't always win here. But we do try and we do learn, and I think today, well, we learned that this is not the solution. I'm gonna need to rebuy my components, come back next stream, and hopefully be less scuff. I'm gonna call it a stream right here, and do a little bit of cleanup. I hope that everyone has had a good night, despite the fact that we didn't get exactly what we wanted. We had a little bit of success earlier, but really, I think just this is not the right module for me. I think this is the type of microphone that you want to have if you are trying to detect really, really loud sounds, but not necessarily if you're trying to distinguish between a human voice as opposed to now it's just blinking randomly now. A human voice sound as opposed to rattling on the table. Nope, doesn't work. Okay, let's go and find someone to raid. Also in the technology channel, Twitch. I hope all of you guys have had a chill night. Hopefully you guys have had a wonderful night to wind down and also hopefully learn a little bit. I know I didn't go over physics as much as I used to for my other streams. What is happening here? 100 days of code. Met a dev girl. Finally learning. Finally learning what? Finally learning some GraphQL. Oh, interesting. Rats making rat stings. This is a rat's camera stream. Might be a little bit gross. More programming. I see some people. Can I find like a hardware project of something that's general relativity? I might just have to send you guys there. This is the appropriate level of learning for people watching the stream of this caliber. Hell, there's mine. Okay, cool. Claw machine live. Ooh. Work on a school project. Feed sheep with cryptocurrency. Interesting. Last time we found one that was what was it? It was a robot, and you can type in commands in order to in order for the robot to perform various actions. I don't think I see that one again. Chicken life. I might send you guys to the general relativity one. What is he talking about? Okay, this could be a little interesting. Just to check, maybe there could be a more entertaining one than pure learning. You always gotta mix the learning with the fun. Surf life saving cam. Interesting. A lot of people waiting for lives to be saved. What else have we got? Dream interactive game dev. Interesting. Alright, we got an ad though. Alright, I might have to send you guys over to the general relativity one. Again, for all of you guys who are still in chat, we do this every Saturday at 10 p.m. Alex says, oh, sorry, wrong chat. Okay. Let me see. Where is our raid button? There it is. Send you guys over to a similar, or at least I think it's hopefully similar channel. We do this every Saturday at 10 p.m. I was a little bit late today and we were kind of unsuccessful with our usage. Carrie Cat, Kyrie Cat, thank you for dropping by, and I hope that you guys have had a chill night. Next time I'm going to be streaming is going to be on Wednesday. It's going to be more Valheim / Genshin content. Hopefully I'll be a little bit more energetic next time. I like lurking to the chill vibes. Yes. And I haven't heard the audio for this one, but they are giving off similar chill vibes. And they seem to have a rather active chat as well. What else? Let me see if I can actually remember that. Not lurk. What am I doing? We have our raid message. This is my raid message. But yes, hope you guys have a wonderful night, and please get some sleep. I might tune in a little bit later to the DGen stream from oh shoot, what is his username? It's a lot of syllables. Kotobashi Camera. No, that's a department store in Japan. But yes, we got 5 seconds on the chat, and hope to see you guys in a future session. Thank you guys for tuning in. Press that raid now button.